So now that we've learned how to open, copy, and share a Jupyter Notebook in Google Colab, let's talk about what we actually do with this thing, right? Let's talk about what this is here for. The information in a Jupyter Notebook comes in two types. There are text cells and code cells. Text cells are things like these first few cells here. And you notice when I click on these things, they get this little highlight. That's because that's an individual cell. A text cell is used for me to give you instructions and for you to give me answers. We'll talk about how to change a text cell in a little bit, but for right now, the purpose of a text cell is for you to read it. If you scroll down, you'll come to your first code cell. So your code cell looks like this. It's got a little bit of a different font. It's got a play button off to the side, and it should have the lines numbered here. If you don't see those line numbers off to the left, I recommend turning those on. You can go over to the editor settings here on the little gear icon and check this box that says show line numbers. That's something you always want to turn on because you want to be able to tell me I'm having a problem in line 3. It's a faster way of referring to these things rather than us trying to figure out what we are talking about. What I hope you'll notice in this code cell, this is the actual code. This is a language called Python. What I hope you'll notice here is I've already given you code to work with. You do not have to generate this. You get to start with this and make changes to it. That is not considered plagiarism. That is considered taking something somebody has written and modify it. That is how coding works. You are not expected to write code from scratch. The biggest thing you're going to be doing in this code cell is adding numbers. So this is part of an experiment we're going to do in class. You're going to have a Slinky. Actually, here's a picture of the demo. You're going to have a Slinky held between you and a lab partner, and you are going to oscillate that Slinky up and down. You're going to give it a pulse, then you're going to give it a wave. And you have a few things to measure about this. You're going to try to measure the length of the Slinky, how far left and right it is stretched. You're going to measure how far along the Slinky your pulse travels that you measure, and you're going to measure the amount of time it takes for that pulse to travel. Now, one of the nice things in a code in a language like Python is that you get to name your variables whatever you want. You're not stuck with X, Y, D, R, things like that. You can call it length of Slinky and distance and time and wave speed. So you get to name those things what you want. So what you're going to do here is plug in the numbers. So I've left in some double question marks here, which Python does not know what double question marks are, so it's throwing an error down here. If you try to run this now, it's not going to know what the double question marks are. Your goal is to replace the double question marks with the numbers that you measured. So let's say I measure the length of the Slinky to be, let's say 1.1 meters long. I don't put in the meters because it's not going to know what to do with meters. I just have an understanding with myself and my lab partner this is going to be in meters. We'll talk about documenting that another time. And let's say I send it forth and back along the Slinky once in each direction. So that would be 1.1 times 2 is going to be 2.2. Now I could actually do this a couple of ways. I could manually put in the 2.2, or I could tell it I want 1.1 times 2, and it will do that little bit of math for me, which is pretty cool. And let's say it takes this little pulse, let's say 1.5 seconds to go across. What's going to happen now when I click run is Python is going to follow all of those instructions one line at a time. And so it's happening. It reads in the length of the Slinky as 1.1. It reads in the distance as 1.1 times 2. It reads in the time as 1.5, and then it calculates the wave speed. Notice it is doing the calculation for me. It takes the distance value, that 1.1 times 2. It divides it by time, so the symbols mean exactly what they mean on a calculator. Asterisk for multiplication, a slash for division, plus sign for additions, minus sign for subtraction, and then it is printing to the screen. This little print command here means tell me on the screen wave speed is a number, and there it is, the number. You could put that in a calculator to verify it, and there it is. Jupyter is doing the math for you.